Greetings, sentient being, and welcome back to Punkworks. I'm Pluto, and you're hopefully going to learn something today. Maybe, maybe not. Who knows? Let's find out. Today we're going to talk about one of the most commonly asked questions by people that have gotten into the game, gotten a little further into the game, like after their first couple missions, and then they're like, oh, there's this network, and there's no open ports for me to directly attack. It's something that comes up, and then generally speaking, not a lot of players get right off the bat what exactly they're supposed to do. So a lot of them will go to Discord, they'll ask around, and then someone gives them a link to a Steam guide that they got to read and follow, and I'm like, why isn't there a video? So here's the video. It's going to be a little bit long one today because I thought I was going to release shorter videos and it would allow me to get more of them out in a quicker time frame, and that turned out to not be the case. My mental illness just doesn't let me do that. So when I do release, I'm gonna make this a longer video just so you have a lot more to chew on till I get the next one out. All right, so let's go ahead and get into it straight away. I have here a network that I've already just randomly, I randomly found this one. It's not part of a mission or anything, but if we look at this network, you see that there's no open ports. There's all this stuff inside, but we can't reach any of this from the outside. We are looking from the outside in, and all we have access to is this router. I went ahead and scanned it to save you, so you don't have to sit here and wait for me to scan it. So let's go ahead and see what we got, okay? So we're looking in here, we do a meta link so that we can link our net session to this router right here. And so we get that, and since we already have a database, it lets me know that the database link is successful. The next thing we do is zap. That allows us to select one of the attacks, and this particular router only has two vulnerabilities, a guest shell and then another one that we don't know what it does because the message said it needs to be executed on the same subnet as the router. So we're outside, we can't do it. So we can only pick number one. Okay, we're going to pick that. We're going to pick a shell, and it's going to give us, a guest shell, and it's going to send it to the buffer and ask if we want to open it. We're just going to press enter for yes. We've got a guest shell for that particular IP address, and we see there are no processes running or users logged in. All we're going to do is the same thing that we would do if there was a port. We're going to pick upload rootkit to go ahead and infiltrate the router. So what we did, just kind of make sure you're still here, we connected to the router with a net session, linked up our net session, and we already had it scanned, so we already know what it is, but otherwise we would just scan it and then find out. And we sent the attack to get a shell on this router, and then we uploaded to the router, so now we're on the router. We can take a look at the file system and its router stuff, and then my rootkit that is just a little bit big, so we're just going to move past that. Now that we're on the router, we want to get root, and since we're using shell, my program, instead of going through a bunch of hoops, we're just going to get root with Brutus, okay? Now Brutus is going to crack the password through brute force, and then it's going to return, it's going to put the shell that it gets, hopefully a root shell, in our buffer, and then it's also going to return that shell so that we can do something with it immediately by piping it into another command, which is, what shell's all about. So we're going to take, and we're going to go ahead and take the shell that we get from Brutus, and we're going to pipe it into Glasspool. Okay, it's accessing the dictionary, it found the password, it pushed it to the buffer, and then it returned the shell, which Glasspool then opened. So now you see that it turned from white to blue. We are now running Glasspool, and you can see that the line under the IP turned from white to red. That means we're root. Just visual indications to kind of help you out. But now that we're running as root, I want to go ahead and copy my rkit to root. Actually, I'm sorry, I should have moved it to root. I should have done this. Sorry about that, guys. I should have done that. Okay, so now we have the rkit in root, and what I can do now is I can run shell again through Glasspool, which will give me a regular non-Glasspool but local root shell on the object. Okay, so we uploaded to a guest shell, we got the password, we opened up Glasspool, so we're mirroring that shell, that root shell. We're using the root shell to launch our program, our script, shell again, from the rootkit, and so now we are running natively on the router. We are on the router running. So now we can look inside the network, and we can see a whole lot more machines than we could when we were on the outside of the network. There's so many machines on this network that it took a minute to categorize all these. So now that you can see, let me scroll back up, all the way up to the first port map. You can see, we only were able to see, routers, and then, something that was connected directly to the router subnet. But all the other subnets we weren't able to see. See, we were only able to see 11 machines from the outside. And then when we go up here and we did that scan, we are 53 machines inside of the network. So there were, 42 machines, I can count, 42 machines that we could not see. You can see all these internal ports that we can try to access now. So we're just going to kind of pick one. I want to try to get, well, those are cameras, so those are useless. This one will have users on it. Yeah, so we'll try to get into that one. Now, first thing we're going to try, now that we're on the router, we have to use local exploits. We have to exploit what is in the /lib folder, okay? We have a few different options. The first thing I'm going to do is select the kernel router that we already scanned, okay? And I'm going to select the one that we don't know what it does yet, just because I want to make sure that I, look at everything, no stones unturned. So I'm going to look at this one, okay? And it says no LAN IP indicated, or it's invalid. This is exactly what we were looking for. This is the way that we get through the fact that there are no open ports. This is a bounce exploit. What you do, now this is something that you only get on routers. Anything in lib could potentially have a bounce exploit, but only if it's on a router. And if you get an exploit from somewhere else that returns a computer object on like a regular server, it will be a bounce if that same lib is in lib folder on a router and you exploit it. Does that make sense? Like if you get a computer object exploit, it is always a bounce exploit when it's on a router, meaning it's going to ask you for a LAN IP. Okay, so let's do that. Let's rerun zap. Okay, we're going to select 2 again, and this time where it says enter IP or password for inject value or leave blank, we're going to enter an IP. That's what goes here, is this right here. So we're going to go ahead and enter that IP that we saved to that secure shell port. That's, I believe it's that one. Was it that one? No, it was this one. It's this one. We're going to go ahead and bust into this machine now. Okay. So we press enter, and what that does, now you saw a bunch of stuff happen. So let's go back up. Zap. Selected exploit 2, and what it did is it ran the exploit. See, there's the memory value, there's the unsecure value, memory, unsecure, and then that's the inject. That's what we sent right there. And it succeeded and gave us a guest level computer object. Okay, so Zap sends the computer object to the buffer and then immediately opens its menu, its context handler or whatever. I call it a handler. It's the computer handler. A few people, I think, in Greyhack use that same term, so I just kind of adopted it. Sounds right to me. This shows you any processes that would be running. There are none running right now, so it doesn't show you anything. Again, it lets you know it's a guest computer, the public and private IP, any network devices that the computer might have, and any open ports and or any running services ports and version. So it's some quick information at a glance that will refresh every time you press enter, so you can sit here and monitor if you want. You got a bunch of commands of commonly used functions that you might need to do, and if you need to do something that's not on here, you can of course hit G and drop into a Glasspool shell. Now, when you're using a computer object, it's not full Glasspool because you don't have a shell object, you only have a computer, and there's only so much you can do. So I call it glass puddle. Okay, it's not quite a pool, it's a puddle. You have almost a pool, but it's not quite. So only computer and file commands will execute. Shell and local general commands will not execute on the target. It'll execute on the machine that you're actually running on. So you got to be careful of that. Usually it's good to just kind of look around and see what's there and explore. So now that we've gotten that, we can look around the file system. We can tree it out if we want and see all of the files that are on this remote machine. I'm not sure why it's running slowly. I think I might need to adjust my algorithm or something, or maybe my network's just going a little slow. I need to redo my tree because it's not very pretty. But I couldn't open the password, but it does automatically throw the emails and banks into a buffer called the transmission buffer, because you can transmit that to home base to have it cracked, but you can also just access it locally. So that's what I'm going to do. Okay, so I'm going to return out of this. Okay, and I could go ahead and crack what's in tbuff is what I call it, and then get there. But I want to show you also, instead of doing what I just did, dropping in a glass pool and doing the tree, you can actually just do the home directory itself. Okay, so if I press 1 right there, then it only trees out the home directory, and of course automatically enters this into a buffer, and it's, I already did it, so it's skipping duplicates so you don't have multiple ones in there. Okay, so now I have 2 email addresses. I have this person and I have this person. So what I'm going to do, instead of, normally I would dump it to a file, but this time I'm not going to do that. I'm going to show you a different way, and we'll do it dumping it to a file on the next example, because we're going to do a few examples. Okay, so I quit out of that. Now, now remember I said that it's stored in tbuff, and you access that by saying @tbuff. Okay, any sort of user-facing variables that I have, like the clipboard or the tbuff or the buffer, that sort of thing, it's always going to be in @ and then at that variable name. Okay, so it's @tbuff, and if I just echo it out, you're going to see what's stored there is an IP address of the target, and then we couldn't get anything out of the password file, but we can get these guys. Okay, so we have tbuff already set, and what I can do is decipher all that with Gopher. So just like that, you can just feed that into another command and it will just use it, because shell loves to just pass stuff around as discrete objects that you can practically hold in your hand. Okay, so now we have the passwords for these. Okay, so what do we do with these? Why did we get these? We're going to use some social engineering. Okay, so this is my mail program. Don't worry about these, we'll get to these later. But I'm going to open up this button right here, log in to a different email account. Okay, so we log into a different email account. We're just going to pick this person. Okay, and then we're going to copy the password, put that in there, and we are now logged in to this NPC's account. And it looks like there's some junk mail, and then a few communications with other employees there. And look right here, they're going to meet in the break room at 11:45. That's useful if you're looking to target a particular employee, but we'll worry about that one later. Right now, what we're going to do, now that we're logged into this NPC's email, is we're going to email this person. Okay, so, and that's what you have to do in order to do what we're doing. Let's go ahead and create a new email. We're going to funny game. This is your backdoor email. This is the email that you use to get a backdoor on an NPC. You're basically sending them, a Trojan. You're telling them that it's a very funny game and that they should open it up, and you're posing as one of their coworkers so that they trust you. If you don't use one of their coworkers, they don't have to be on the same machine, just anyone on the network. If you don't use one of their coworkers, they won't open it. And if you do want to use one of their coworkers, they will, as long as you get all the stuff right. So the next thing we're going to do is give it the IP address of our reverse shell server, because this is a reverse shell is what it's going to send them. I have a second window on my attack proxy that we're using, so I'm going to open up the reverse shell interface, and I forgot that I turned silent mode on, so reverse shell interface, and it says no nothing's connected right now. Okay, so I can use -D to run it in daemon mode, and now it will wait until a shell connects. What we're going to do is we're going to enter our IP address for our reverse shell server, and you can see it at the top of your window. Even if you're connected to another machine, as long as you don't do start terminal, your starting point will be at the top of the screen. So let's go ahead and enter that. That's 167.251.160.217. Okay, that's our reverse shell server. So we apply that, and you see it took it, and then you send it. And they say, I just ran it, I hope it's gory. And you can see right away, this popped up with Matt running the reverse shell client, the Trojan that we sent them, the back door. We don't need this anymore. We can delete this if we want, but why not? Why bother? Okay, so it brings up another menu. Let me go ahead and make this. Actually, yeah, no, I'm gonna show you some more advanced stuff later, but right now we'll just do it the easy way. So this is the machine that we're trying to get onto. Okay, remember from here we're still on the router. We couldn't just break right into that machine because we didn't have a shell on it. Now we have a shell on it. So remember, glass pool. Let's go ahead and do glass pool, and we can look around on this machine. We can tree it out. Once again, it's the same information that we already knew, but again, we're just on the machine. So what we would like to do, okay, what we would like to do is get our rootkit up on there, okay, because we're trying to hack the machine. So just like in the buffer, you can press 3 to upload your rootkit to infiltrate the target, okay? So we just do that, and now we are running on the target. Look at that. Now we're there. Now we're not root, we're Matt. We're that user that we logged in. And let's see. Yeah, let's go to his home directory, and we can see, there's like a chat log. Let's go ahead and open that up again. And there we can see the contents of this log on that remote machine. Nothing actually exciting, just letting this. Nothing. It's a big nothing. So there's not much actually on this particular machine to do anything with, but we got onto the machine. So let's go ahead and get root and destroy it. There we go. Files nuked, reboot when ready. Let's take a look at the file system, and a bunch of critical files have been removed. The lib folder is gone, the boot folder is gone, the system folder is gone. Home and all that stuff stays there because that doesn't matter, but all the critical files needed for this machine to boot are gone. And I think we can just go ahead and reboot it. Yeah, see, it's gone now. And that dropped us back to where we were originally, and sometimes this can cause problems, so I'm just going to go ahead and close that. But as you can see, we still have, we still had that in memory, and since that shell is no longer valid because that machine was rebooted and destroyed, that object is no longer valid, and it crashed out because I don't actually have a way to programmatically tell reliably that that object is no longer valid, and so if it is, it'll crash. If it's no longer valid, it'll crash. But we still got onto the machine and did our dirty work and came back. Okay. So the next thing to do is to go ahead and clean up our tracks on the router that we were on. And that is simply using silent clean once again, and instead of -n, we use -d. We could, of course, nuke the router too, and why not? Let's go ahead and destroy the router as well. Okay, now we won't be traced back to our home base, and we just exit all the way back, and we are now back on our proxy machine, having successfully done what we set out to do. Okay, all right, so that was one example. The next, we're going to go into a more advanced example in the next one. So go ahead and grab a snack, take a break, and come back, and we'll do the next one. Okay, let's look at a new network here. This one's part of a mission. I figure it'll be a little bit better to give us some context behind what we're doing. So what we're doing right now is the client wants a remote machine to stop working. The remote IP of the victim is 26.168.55.15, and it's important they access the correct machine behind the public IP, the victim's IP LAN. I think that should be LAN IP, but who cares? The victim's LAN IP is 10.0.16.12. Now remember to restart the machine after deleting or corrupting the system files so that it cannot boot. And be careful, since the administrator will want to know who is responsible. So we got to find this machine, and we got to bust up the files and reboot it. Okay? And we got to make sure we don't get caught. So you notice this is another network with no open ports. You know, nothing to attack except for the router. Okay. Now we can see that behind the router there are a couple machines that are there that don't have their ports forwarded, but they're still there. But they just don't have any ports. So we're going to try to get onto those machines. Now we're going to go ahead and link up, and we do not have this database yet. Okay, that's what when it's this color, it's not databased. It'll turn cyan if it is in the database, but we don't have it in any of our database files, so we have to database it. Okay, and that is just db-r for a remote databasing of what we're already linked to. Okay, so we're going to go ahead and do that. Okay, we're done with that. We see we have several different options for what we can do in attacking this machine. Now in the last example we had a guest shell, we got onto the router and we did a bounce from there. In this particular case we can actually bounce directly from the router from outside of the network, which is pretty fortunate, especially since we already know what IP address we would like to bounce to. So let's go ahead and do that. Now that we've databased it, we can use zap, and we select one of the bounces. We're going to use that one right there, number 2. And it asks for an IP. That is the LAN IP that we would like to bounce to. Okay. So remember, we're going through the router. Okay, bouncing from the router to this machine, like so. Now we got that computer object. You recognize we've got a process. There is a user that is running a D session. That just means that a user is logged in. A D session is an NPC is logged into the computer. Okay, and this one doesn't have any ports, as you can see, no port info, and IP network card. And what we're going to do is the same thing as before. We're going into that home directory. Okay, going into the home directory. Now we have 2 users on this machine, which is super fortunate. Okay, we can use either of those, and so we're going to do that. Oh, we have to decipher them first. Okay, so what I'm going to do is number 3. Okay. Actually, just for the sake of it, we don't really need it, but I'm going to do number 2, which is it tries to open the password file. They don't have permission to read it, so there's nothing there. So we'll go ahead and do number 3, tdump. Okay, dumping to tbuff to root pass. Remember, the tbuff is where it goes when we do this. Okay, goes to transmission buffer, tbuff. Okay, and then what we just did is dumped it to a file. So we put it in root pass, see, right there. Okay, so we exit out of this, and if we look in our directory, we see pass. If we look inside of it, there you go. That's the stuff that we just got. And we can use gopher. Let's go ahead and look at the help file for gopher. It's just, path to file or a file object or hash string. You can give it basically anything that might need to be deciphered. You just pass it in. Okay, so we're going to decipher a file, gopher, if I can type, pass. Okay, and oh, did I not have the dictionary loaded up? Oops. Yeah, let me, sorry about that, guys. For some reason I didn't have the dictionary loaded up. That's really strange. Oh, wrong IP address. So, okay, so that was a weird mistake, but I'm going to leave it in just so you can see how I recover. Okay, so I didn't have the dictionary loaded, so I exited out and I'm going to restart. The dictionary's definitely in now. Let's double check. Yeah, see, dictionary's loaded. Okay, so we're going to go ahead and probe that same target that we just had. Notice that we have a database now, so we can simply link to it. Database successful. I should probably change this to green instead of orange. Orange makes it seem like it's an error. I'm going to change that to green. Anyway, here's what we're doing. Okay, we already linked it, so zap 2 and right back to our target. See that? All right, so we're going to do 1 and then 3, and now we can go for pass. There we go. I'm not sure what happened to my dictionary that time, but things happen that I just kind of don't really know sometimes when I do something. So we're going to break into this person's email. There we go. Password. There we go. Let's see, we got a junk mail, junk mail, junk mail. Password as is. All right, fix it. Okay. Little employee-to-employee communications. We don't really care about that. What we care about is dropping the R shell. Get my little IP address there. There we go. And we're going to email this person right here. When we do that, they're going to open the Trojan, and then we access our reverse shell interface with our RSI. And you see here, that they opened the reverse shell. So we're going to go ahead and do number 1. Okay. And as usual, I like to just go straight into Glasspool. Okay. Now I'm looking around on the target. We're not root. See, it's green. We're a user right now. So we need to escalate to root, but we can't do that while we're in Glasspool. We have to run shell on the target before we can escalate. Okay? So what we're going to do is we're going to copy up the rootkit, and we're just going to return and do it the easy way. RSI 1 and then 3. Okay? There we go. Now we are running shell on the target. We're not in Glasspool, we're just regular running, which means we can get root and then jump right back into Glasspool. See? There we go. Now we are root in Glasspool, so we need to do one more. Actually, no, I was actually gonna go ahead and move this to here and then just go ahead and launch again so that I'm running as root, but I just realized I don't actually need to do that. I can actually do what I need to do from Glasspool. So I'm just going to go ahead and back out since I don't need to do it there. I'm in Glasspool and I do silent clean -n. SC is short for silent clean. If we look at the help file, you can see it's giant, but it's actually, I try to highlight the things you need to know. Silent clean -d, silent clean -n. All of this is just extra information that you need to know about why you want to use this, but this is the usage right here, so don't get intimidated by this help file. It is just either silent clean, or if you want to remove the rootkit, or if you want to destroy the whole computer. Okay, all this is supporting information. So what we're going to do is silent clean -n, and it's new. Now I want to do a little bit extra, so I'm going to go with core-s capital S, which is just going to shred. Now you can see there's next to nothing left on this system. I'm going to leave the rest of there. You can see the log file has been corrupted. If we look inside of that, nothing. Okay, it's destroyed, and I actually got rid of the reboot binary. I got another way I can do this. All right, so we're going to go in here and we're going to grab our root shell. Okay. Remember, this is an advanced tutorial, so we're going to deep dive into how we do this, okay? So we're going to grab that root shell, and I'm going to get a computer object from it, okay? Computer has been sent to the buffer, so I'm going to back out of here. I'm going to go back into my buffer. Now I have a root computer object for this exact same machine, okay? I'm going to go into its handler. Looks familiar, right? Yeah. Okay, so you don't notice there's not a reboot button on here. It's a new addition that you can actually use reboot through script, so I haven't actually put that in there yet, so we're going to go to the decompiler. You press D for decompiler. It takes that computer object and it strips it down to its base functions and gives you a menu. And you can see right here is reboot. So that's what we're going to do. And we don't want safe mode, boom. All right, so that did a bunch of stuff there. As you can see, it closed a bunch of windows and then it crashed us out because that's what happens when you reboot a machine. So I'm just going to open up another window, and with shell, you can do that simply with NT, new terminal, okay? And it will pop open a new terminal for you. And I'm just going to close this real quick because I just want to show you you can also pass parameters to it. Like I can say NT shell, right? And you'll see this time it opened up shell for me. Pretty cool, right? Okay, so now we blew up that machine and then our script crashed because we blew it up. So one thing I want to do is double check that network. Okay, we're going to link to it again. We're going to zap it again. And this time I want a shell object on the router, okay? Because I want to cover my tracks. So I'm just going to grab that shell object and I'm going to leave it in my buffer. And then I'm going to do something else, okay? I'm going to go ahead and bounce to the machine that we just blew up. Because I want to make sure that it's still gone. Okay, you can see it's still blown up, and the system log is still a text file, which means it is corrupted and we did not leave a trace on that machine. Okay. However, there is a trace of us on the router. Okay, there it is. Sorry, this is the router. Okay, and what we want to do is make sure that we get rid of our log, because since we have a shell, we did leave a log on the router. Okay, so we're going to go ahead and do the same thing as usual. Upload RKit. Okay, now we're on the router and we're running our script, and I'm going to get root, pipe that into Glasspool, and this time I'm going to be lazy. I'm going to tell Glasspool to do what I want it to do automatically, and we do that with -d, and then we tell it what we want it to do, and we put that in quotes. Okay, so it passes it all as one parameter, and what I want it to do is silent clean -n. I want it to blow up the router. Cover my tracks and blow up the router. Done. Okay, I'm going to do the extra. I'm going to do a little extra there to do the shredding, and then there you go. There's just precious little left of this router, and no traces of us whatsoever. And so we leave. We leave again, and we are done. Okay, and you see that I exited the router, but since I never started the terminal, it's just a bunch of nested launches of shell. Then, I didn't have to worry about a disconnect log. So if I go back into the buffer, since I still have that shell object, you can see there's the shell right there for the router, and I'm going to jump back in there, and I'm going to jump into Glasspool, and there you go. System.log is somewhere there, right there, still corrupted. Okay. All done. Okay, so that was a slightly more advanced example with some more steps, but still the basic same thing. We probed our target. Okay, we probe our target. Oh, sorry about that. Yeah, it does that. I should probably change that so that it doesn't do that, but it's trying to find the router because I gave it the wrong IP address. Okay, so there we go. As you can see, there is no response from that router. It's blown up. Okay, gone. So that is that. Let's go ahead and reply to this email, and you can see the customer is satisfied with the job, and there's been an income to my account. So the next one I'll do regular, and then I'll go back through it again and I'll show you how to automate it. And then the final thing that we'll do in this video, at the very end, is we will write some custom code so that you can see how to automate it outside of shell, so that you can do it yourself and you're not completely reliant on what I've made. I want you to be able to walk on your own 2 feet. So we'll teach you how to do that. Alright, so I'm going to go ahead and take another break, and then grab yourself a snack, and then come on back. quick intermission. I just wanted to throw this out here. I am the creator of Shell, which is the program that you see me using here. This is Shell, this thing I made. Now, you might see in game this website right here, coffeeshop.com, claiming to have Shell for download. This is not mine. This is not mine. Do not download Shell from here. Only get Shell from the GitHub where it is safe. This is like, I haven't had these 5-packs in like 3 years. So this is an ancient version of Shell that you should not get. And I've already got the Gray Bureau of Investigation investigating that site to find out. Because that's the kind of PvP stuff that goes on in this game. Alright, let's get back to the lesson. So now we have another mission where it's the same thing. I just picked kind of a bunch of random ones. But it's the same thing. We want the remote machine to stop working. It's at this IP address, and that's the particular machine that we want to destroy. Okay, so we're looking at that, and there are no open ports. So we've databased the router, and we know what's on it, so we're going to link up to it, and we're going to see what our options are. We have a root shell, that's super useful. We have a guest bounce, firewall disables, and another guest bounce. So this can get us to our target, and this will allow us to cover our tracks on the router so that we're not, detected. So let's go ahead and do that one first. Let's cover our tracks on the router, and to do that, since we have a root shell, we can just do number 5, which is just scrub the log. Done. Okay, next step, let's go ahead and get a computer object on our target. There we go. See, root and a user is logged in. So we're going to grab that, and we're going to dump that to a file. Okay. And that's in there, and we've got our dictionary loaded up. So we're just going to go for the file. Now we only have one user's email address, and this is the user that we need to email. So we can't break into this one. We need to find another user on the network, which is not actually going to be a problem because we have other machines that we can choose from. And I'm thinking the SMTP port is going to have a user on it. So let's go ahead and get that one. So once again, we zap, we 9, and there we go. We've got some more emails. And there we go. Okay, so we can use this email or this email to send the Trojan to our target. And I just want to show you, whenever you use Gopher, your results are dumped to a file so that you have them for the future. So what we needed to do is email this person right here. See, I can go ahead and up there, and you can see that. But go ahead and grab one of these. So I'm going to use Ekman. Go ahead and log into Ekman's account. Password. Ignore their emails. Put IP address. There's that. And then we email our target. Okay, sent, gory, right there, rootkit. Okay. Whoops. Here, let me do that again. -d sign clean -n, and there we go. And we return. And let's see, we exit out of that. Infiltration is complete. Close that out. We reply. And the customer is satisfied with the job. Okay? So that's, now that you've seen it, a few times, you're probably like, okay, well, that's actually kind of easy. And you're right. Once you get the hang of it, it's actually I've tried to make it as simplified as a process as I can. Attack the target, dump the info, decipher it, send the mail, do the thing, So let's since we can do all that, we know we've done the steps over and over again, we can put that into a batch script that handles most, if not all, of that for us. I'm not going to do a full-on, fully automated one. There's going to be a little bit of interaction necessary, but for the most part, it's going to do all the heavy lifting for you. So let me go ahead and get that ready for you. As promised, this chapter is going to be on automating the processes that we've gone through so far. We've already seen a few different ways to do it. They're all pretty much the same with slight variations. And with shell, it's possible to simply put all of those commands into a batch script that you can then execute whenever you want. It's basically like a giant macro, wherein you can, of course, define macros and reference other scripts within that. So it's basically you just write another program in order to control shell. It's pretty cool. So what we're going to do is use that specific tool. It's called dig. It's DIG, and if you look at its help file, it's a net crawler auto hacker kind of thing. I should probably add some color to the help file to make it easier to read, so I'll be sure to do that on the next update. But the main important thing is you point it at something. So you either, you point it at an IP address, and it uploads. What it does is it'll scan your target, probe and scan your target. It'll upload the rootkit. It'll get root and do a few things like the default settings of dig.bat does these things. Okay. Now, if you edit the file, either by hand or using the --edit flag, you can define custom behavior. And the file itself that we're going to use, it resides in your rkit folder, and again, it's called dig.bat. Now, it's basically the same as a do script. Here, we can, I'll show you. This is the one that we're going to make. I'm going to go over this with you guys, but this is basically what it is. You can put comments in to let you know, like what each line is doing. Like right here, we can put a comment in, probe and port map the target network. A lot of words to say. We're going to use probe-q, and then down here we're going to create a macro to fire on upload. Like once we upload the rootkit, we're gonna execute this macro. But first, we're gonna create the macro, and then we're gonna call it down here. So we're gonna create a macro that's gonna do all these things. It's not gonna do them when we create the macro. It's gonna do them when we call it down here. So this line's gonna get root. Okay. Get root. Store it in clip A. Get root. Store it in the clipboard, so we can use it in the next line, which is use glass pool. If I could type. Use glass pool to fire the macro on the root shell in clip A, is what we're doing with this. Okay, so use glass pool to fire the macro on the root shell in clip A, which is going to be glass pool -d means do this, and it's going to be the macro move them, and then it's going to be on the shell stored in clip A. Okay, and we made this into a macro so that this line's easier, because otherwise it would be that, which is, it's just a little easier to break that up, into a couple steps, I believe. Anyway, once we do that, we're ready to rock. So we're going to load the vulnerable lib, and that is init.so. Okay, and that's what the macro, by the way, is doing. Is it's scrubbing the log, it's moving our vulnerable lib into lib, and then it's going to move its dependency, and then it's going to drop a reverse shell, and then it's going to drop back out of glass pool, and then do this right here. Load the lib. It's going to use zap and this particular value, memory address and value, and inject, because this is our target right there. You can see 192.168.1.3 is our target, and we're going to use that for our inject. And then the result of this is hopefully a root computer object that we're going to store in the clipboard. Okay, so fire the exploit and store the result. Okay, We're going to fire the exploit and store the result. Once we're done with that, we're going to cover our tracks by deleting the rootkit and destroying the machine. Oh wait, no, this is the wrong one. This is actually destroy the target. Okay, so that's going to use rclean-n to remove all the system files necessary for it to boot on the root computer we stored right there. Then we're going to run reboot on the machine to reboot the machine. Then we're going to drop back and scrub our log on the router that we initially uploaded to when we ran the script. Okay, so remember, we're uploading this to the router, the target's router, and then from the router we're using our lib that we know will give us a root exploit to get further into the network to destroy the target, and then we clean our tracks on the router itself and then drop back to the original terminal. Okay, so let's go ahead, and I'm just going to go ahead and wipe this off. Okay, and we're going to type it up one more time just so we can go along with it. So let's go ahead and type it up by scratch. The first thing we're going to do is probe-q to take a look into the network. Probe-q makes it so that you don't have to enter an IP address, it just does your local network. It is functionally equivalent to doing this, which is to get the public IP of your local network and then probe it. Okay, so it's just a shortcut into that. The next thing that we're going to do, next we get root and store it in the clipboard using Brutus and then storing it in clipboard A. Taking a look in our rootkit folder, our rkit folder, we see that we have a file named init.so and another one named appclient.so. Init.so contains a vulnerability that will give us a root computer bounce when used on a router. The particular one is version 1.0.8. That is the one that we're using. Yeah, there we go. Lib init.so 1.0.8. Make sure that when you use your own, if you don't find this particular one, you'll need to make sure that you database it properly and use one that has a root bounce. If we were to take a look in our exploit things here, the one that we're going to use, go up here and see if I can find it, is this one right here. Now it says null because I databased this on this machine that is not a router. So it says no, but once we run it on a router, it will give us a root computer bounce. Okay, and you can see it has a few dependencies. The path bin has to exist, and there has to be a guest active user, and there has to be at least one registered user on the machine, which is, you know, if root's registered and we have a guest something or other active and bin exists, it'll be good. So that's all we got to do. All right, so going back to the script that we're making, we're moving those two files into the lib folder. Okay, then we're going to drop a reverse shell just because we want to make sure that we're being thorough, and just in case we need to go back and clean the log or something. Okay, so we're going to get the IP address, the public IP address of our reverse shell server, the one running the reverse shell. Okay, and we're going to say that that's where we want to send it. Okay, and the last thing we're going to do, sorry, didn't mean to do that. The last thing that we're going to do is, of course, return from Glasspool. Okay, we're going to do all these things when this macro runs, then we're going to drop back to the line. Once we set the macro, we're going to go ahead and drop a reverse shell to satisfy the guest user active dependency. And yeah, reverse shell is a really easy way to make that happen. Is if you have a guest shell, you just drop the reverse shell and you're good to go. Okay, so we're going to do that, and that is as simple as doing the same thing. So when we do it this time, when we first upload to the target, we're going to be in guest most likely, and so it's going to drop a guest level reverse shell. Next, we're going to use Glasspool and the command flag -d in order for it to do the instructions that we're telling it, and that is going to be the macro that we want to fire, along with the shell that we would like to fire all of these commands on. So Brutus stored that shell in the clipboard. We made the macro, we dropped the guest level reverse shell, and then we are using this shell to run this macro. Okay. Now, once we do that, we're going to drop back to our normal shell, and we're going to load up the vulnerable lib that we have. Okay, and then we're going to zap it with the parameters that we already know. For this particular lib, it is this memory address, and it is this vulnerable, same thing, this vulnerable value. And then the target itself is the LAN IP now. We want the LAN IP, and that's what we're going to zap, is to get to that LAN IP. Once we do that, we're going to store the result, which will hopefully be a root computer, in the clipboard. And with that root computer in the clipboard, we are going to disable the target. Okay? We use rclean-n to nuke all the files, and we're going to perform that function on the root computer in clipboard B, so at B. Okay? Once we do that, that machine will be toast, and the last thing to do is to scrub the log on the router and then get out. So we're going to use rclean again, and this time we're not going to nuke the router, we're just going to do -d. Okay? And we're going to do that on, remember, the root shell that we originally got on the router. Okay? And then we're going to exit with the option Y so that it just exits without a prompt. And all of that is going to get saved in your dig.bat file, which is located in your rkit folder. Okay, it's going to get saved in this file right there. And there you see the instructions that will follow once it uploads. Now notice we don't have anything here to scan the target or anything, and that is because that is what dig will do for you. Again, if you look at the help file, once we fire it at an IP, it's going to do some actions, and one of those is going to be database the target if necessary. It'll run db on the target if necessary. So now that we have all these together, we can go ahead and fire away. Okay, so now we are ready, and let's take one more look at the network that we are, oops, that's not it. Just kidding. Okay, let's take one more look at the network that we are about to infiltrate. Okay, and whoops, that did not. Now let's take one more look at the network that we're about to infiltrate. And we still need to database this because we don't know what it is, but we're going to let the dig command take care of that for us. Okay, so all we have to do is tell it to do it. Okay, and there it goes. It's going to go ahead and do its scan, and once that's done, it'll upload the rootkit, and away it goes. Alrighty, here we go. And it's uploading. And it's going to go ahead and run shell, probe the system. Now it's going to get root. It's going to run our macro. You can see the reverse shell showed up. Oh, I actually made a mistake. I didn't actually get the reverse shell run because you can't do that through Glasspool. You have to actually run the thing, but that's okay. That's okay. We don't really need it. Okay, we drop out of that, and it goes through and does all that. There's a check in here that looks for the rootkit, and it unfortunately thought that it couldn't delete it because it didn't have permissions, when in fact it could not find it. So there was basically a double error that didn't even need to print because we didn't need it. But it did successfully delete boot and scrub the logs so that we are in fact in the clear. And then back on the router, it did find the rootkit and deleted it. And then it's got all its stuff done. And then it go ahead and returning to the original shell session, we have completed the mission, and so we will reply. There, the customer is satisfied with the job. There's been an income to our account. So kind of glitched here. Right here, this didn't quite get us what we wanted, but that's okay. All we had to do was press enter, and we were still in the clear, and we still managed to scrub all the logs and everything. So that's how you would automate it with shell, and it's, I would argue, incredibly easy to do this. When you're setting up a macro, it's just the same as if you were typing the commands out on the command line. It's the same thing. And this is basically the same as if you had pressed enter. Now if you have 1, it's of course a pipe where the output of this gets piped to the input of this, but if it's 2, it's essentially like a new line character. It just pops onto the new line. Okay? Let's go ahead and remove all that. And that's pretty much the macro, or the script, the batch script that you would use. And of course you can modify this to do other things, and specific to the library that you're able to use that you'll probably have to find in game, of course, and setting in your own values. So it's not completely automated. You'll have to set this up for each individual target before you press fire. But once you press fire, it'll do the thing as long as it succeeds in getting what it needs. And I'll fix that error message that doesn't need to be there. Alright, so the last thing we're going to do is figure out how to do this with your own custom code so that you don't need shell to do it. You can write your own. Okay, so chapter 4, the final session here, we're going to write ourselves a little automatic infiltrator like I just showed you using shell, except this one's going to be our own custom standalone code. It is going to be in 2 parts. One half starts the process, and the other half finishes it. Okay, so just like before, we had the dig command that dug into the target and established a foothold, and then ran the ran the commands in the file dig.bat. So what we're going to do here is we're going to have this act as the command that uploads and infiltrates, and then it's going to run a secondary script that will act as the batch script that gets all the stuff done. Okay, so let's go ahead and go through these one bit at a time. First thing we're going to do, we're going to make sure that we've got 3 parameters, and those parameters need to be the memory, the value, and the IP of the router that we're attacking. Okay, so if you look at our mail, the IP is going to be the IP of the target that we have been attacking. Okay, the memory and the value are going to be the values that we already know exist as vulnerabilities in the router that we're attacking. Okay, so remember, we've already done this one, so we already know the vulnerabilities, and we know that we can get a guest shell using these values right here. Okay, now we're not hard coding those in because we want to be able to reuse this script on any target, so we will scan the target ahead of time and then fill these values in when we want to use them. Okay, that's that part. Okay, param 0, 1, and 2 are, param 0 is this, params 1, params 2. Okay, 0, 1, 2. Okay, all right, so once we've got that taken care of, we're going to load up the necessary things that we need to know, which is the meta exploit library so that we can do the exploiting, and we need to know where our RKit is because that's what we're going to upload. Okay, and if it's not there, we are like, no. The next thing we're going to do is we're going to get the net session for our target using meta exploit as we have up here, and we're going to use the net use function, and we're going to point that at our target and port 0 because we're just attacking the router, so that's port 0. Okay, so that's our target, that's the IP. And once we get that, we're going to get a metalib by dumping it from the net session, which is a very straightforward process. So once we have that metalib, we overflow it. Okay, we overflow that metalib using the memory and value that we entered when we ran the program, which will get us a guest shell. Using that guest shell, we upload our rootkit, and before we do that, we switch it to read, write, and execute that guests can use, others can use, and we make that recursive on the whole folder. Okay, we then upload our rootkit to the guest folder of our target using that guest shell that we got. Once we do that, we switch the read, write, and execute permissions for guest off on our folder so that it's as secured on our server, and we make sure that that is recursive. Okay. Finally, we launch, well, not finally, but for this script, we launch the secondary script that we have defined over here, and that is going to actually do the payload stuff. Okay. So this is the infiltration portion. And of course, if we didn't get a shell, it says we failed. So that's the infiltration portion. Over here, we have the actual business end. And that includes, again, you include your meta exploit lib so that you can do your overflowing. It's going to be in your rkit and guest folder, just like you uploaded it. And then you're going to need to get a root shell on the router. And to get a root shell on the router, you can either write code to exploit libs in the router folder, or the router's lib folder, so that you can try to get a root shell that way, or you can write your own brute force code that is basically using a word list that you get somehow. And then for every word in that word list, you attempt get shell, and then passing it the root user, and then the word is the password. And if you get a shell, then you return that root shell. Otherwise, we failed to get a shell on the target. And so that's going to be your homework, by the way. Okay, I'm not going to, a shell comes with a word list. You can use shells if you want. Otherwise, you can write your own or find your own, whatever you want to do to get your word list. You're going to import that somehow. Okay, and that's your homework, is to figure out how to get your word list into this function. Okay, otherwise your homework is to write code to exploit the lib folder as guest and find a root shell that way. Okay, now once you do that and you got that root shell, you're going to use that to do what we did before, which is first we're going to isolate our two files that we're going to use, our init.so and our apt client. Those are that's our payload, and we're going to move that payload into the lib folder where we can exploit it. Remember, it has to be in the lib folder in order to be exploited. Once you do that, we're going to use meta exploit to load up the init.so and store that as a meta lib. And then you're going to use that meta lib and you're going to overflow it using the values that we already know in init.so's vulnerabilities. We already know that's going to give us a root computer, and we're going to aim it at our target, which is the LAN IP 1.3. Remember, public LAN. That's our individual target. This is the address of the apartment building. This is the individual apartment within the building that we are redecorating. So once we redecorate by removing the boot folder, deleting it, we spoof the system.log by creating a file using touch in the var folder. And I actually did this wrong, so let me fix this real quick. There we go. It's actually it's supposed to be like this. Var and then the name. We're going to call it a spoof. Then we locate the spoof file so that we can manipulate it by moving it over the actual system.log, thus corrupting it. We then reboot the machine, and then we remove the rkit folder on the router. Remember, this root shell is the router. This is the root computer of our target. This is the root shell of the router that we uploaded to. We delete the rootkit, and then we use that root shell to do the same spoofing, where we create a spoof file and copy it or move it over the system.log. And once we've done this, we are finished. Okay. Now I'm not going to run this, because if I do, it's not going to work, because this is an incomplete function. Okay. However, once you've completed this, it will of course run. So let's go ahead and just see what happens when we do actually run it. Let me go ahead and save and build these. Save and build. Okie dokie. Let's go ahead. Okay, so finally we're ready to fire the exploit that we've created. Remember, it's not going to actually work because we're not going to be able to get root because we don't have a proper get root function. However, the rest of it should work just fine. So let's go ahead, make sure I get this information right here. LAN IP of our target. Oh wait, no, I'm sorry. We want the public IP of the router for our target. There we go. Okay, so it got a guest shell. It's uploading the kit. And then it's going to say we failed to get a root shell because it got this far. But we already seen that if it did get a root shell, it would do all these things just fine because we already saw it do it. But that's essentially what you're doing. And this is, of course, your homework. So I'll leave this on the screen here so you can see this part. There we go. Okay. Okay, go ahead and pause and copy that down. I'm going to remove this down. So this was the bottom of the screen before, so you can copy this stuff down. And remember that this line right here, you're going to need to customize for your own, this whole thing right here, like this file and this stuff. You're going to have to customize this to work with what you are going to use in your payload. Okay. But this stuff over here, of course, you can just reuse over and over again because you're going to enter the variables as parameters. Okay. And there you can actually make it even more advanced where you enter all the parameters here, including what you're going to use down here. Okay. You can use the custom object and that sort of thing to pass information between these two. You can make this as super advanced or as simple as you want. Okay. So there's the bottom half. There's the top half again. And if we want, we'll take one last look at the batch file. Whoops. Sorry. We'll take one last look at the batch file that we made for shell that also performs the same functions as the two programs that we just wrote. So there you go. In all its glory, that's how shell does it. Looks a lot less complicated now you have the perspective, right? So hopefully this helps you guys out a lot. Definitely, if you want to see more kind of stuff like this, like, subscribe, give me a comment, let me know what kind of stuff you want to see. Any kind of feedback, positive or negative, is always useful, so don't hold back. And otherwise, keep learning, stay punky, stay cool. Bye.